All right, so circles and circumference. Okay, here's the official definition of what a circle is. A circle, this is how you can impress your friends at the next party. A circle is the locus of all points in a plane equidistant from a given point. And that point is called the center. Miss Malikian, what are you talking about? Well, here's what I'm talking about. Let's put a point right here. We're going to call that C for center. Now, okay, so go ahead and do that, everyone. Now, go ahead and put another point, and eyeball it, like about a centimeter away from that point C. Like right there. Okay? Now, can you please put a second point a centimeter away from C? Just somewhere else. Oh, maybe here. And let's do another one. A centimeter away from C. A centimeter away from C. Another one. And another one. Let's put another point 1 centimeter away from C. Let's put another point 1 centimeter away from C. And another. Pay attention now. And another. And another point a centimeter away from C. What is that looking like? A circle. So if you get, well, you gotta calibrate your estimation here. If I put down all the points possible that could live 1 centimeter away from C, they would trace out a perfect circle. Okay? Now, these red points are each a centimeter away from C, so they are equally distant from C, right? So going back, a circle is the locus or the set of all points in a plane equidistant from a given point C, center. All right? So if I were to tell you here is C, draw all the points, 10 centimeters away from C, then you would have a circle that's, that much bigger. All right? So that's a circle. All right, how do we name circles? Throughout the year, we've learned how to name angles, lines, planes, whatever. A circle is named by its center point. Okay? So for example, if you have a circle with a center C, we write it like this, and the way you would do it is you would say circle C. Make that a circle like this. Okay? Circle C. All right. You have to have a dot in the middle of the circle, otherwise it's just OC. Okay? All right. So so this vocabulary you all know, right? A radius is the segment with endpoints at the center and on the circle, right? So that's a radius. You all know all this. Okay. A chord, different from what it is in music, is a segment with endpoints on the circle. So you just start from one point on the circle, go to another point on the circle, but not passing through the center, right? That's a chord. A diameter is just a chord. It's that one specific chord that passes through the center of the circle, right? So if I were to draw a chord here and just pass, and go here, and you're like, oh my God, that passed through the center, that chord passed through the center, then it's a diameter, okay? All right, all these are segments, right? So when you want to name them, you have to have the segment bar on top. Now, the next two we're going to talk about are lines. A secant is a line that intersects the circle at 2 points. Now, let's talk a little bit about the difference between a chord and a secant. A chord is a segment with endpoints on the circle. It's got endpoints on top of the circle. It starts on the circle, ends on the circle. A secant goes through the circle and it's a line. A tangent is a line that intersects the circle at exactly 1 point. So it's like this is a circle and this line is, coming over and it just brushes the circle at one point, just at one point. That point is a special point called the point of tangency. Now let me tell you something. These two terms, a secant and a tangent, along with point of tangency, are things that are going to stay with you the entire time you take math right into college. In AP Calculus, we talk about secants and tangents almost every day. All right? Okay. All right, so let's see. Name the circle. What do you guys think? Circle C. So this is circle C. B. Name a radius. Tell me a radius. Nope, radius. CD. It has to be segment CD. If you just do CD, you will not get any credit because we learned segment notation back in chapter 1. You were, tiny little post 8th graders at the time. Now, you're practically 10th graders, so no more, oh, I forgot. Okay, name a chord. BD, segment, right? Name a diameter. AD, obviously you could do DA, just put the segment bar on top. Name a secant. BD, but with a line symbol. What about a tangent? EA or AE. Where's the point of tangency? A. Point A is the point of tangency. Good. Okay, so circle A has diameters DF and PG. If DF is 10, find DA, right? So DA is a radius, and how is it related to a diameter? It's half of it, right? So a diameter is 2 times R. So how much is DA? 5. And if AG is 12, then how big is LA? LA. 12. Also 12. So LA is also a radius. So let's take a look here at all the radii. PA is a radius. AG is a radius. AF, AD, LA, all of those are radii, and they're all equal to each other. Okay. Oh, I love these problems. I love these problems. Look at example 3. The diameters of A, B, and C, circle A, circle B, circle C, are 10, 20, and 14 inches. So the diameter of circle A is 20 inches. That means, how big is this part? 10. Ooh, 5. I'm sorry, I meant, okay, sorry. The diameter of circle A is 10 inches, so this is just 5. Sorry. Yeah. Okay, so hang on. So the diameter of circle B is 20 inches. So how much is this one? 10. No, yeah, I'm saying the whole thing. And now the diameter of circle C is 14. So this is 7. Okay? And now, okay, so how much is XB? 5. And BY? 3. Right? Because this is also 10. And this is also 5. Okay? All right. Questions? Questions? I feel like you have a question.
Like, I don't know where you got
the 3. So that was BX, right? I'm sorry, which one? Oh, BY. So BY is this little part here. I'll do it in black. BY is this one. Okay? And you see how from B to C it's 10? Yeah. And this red part is 7? That must be 3.
Thank you.
Mm-hmm. Okay. All right. Now, circumference. Circumference is the distance around the circle. And I really want you to really know what this means. If there was a perfectly circular track, and you just walked around the circle, and you monitored your steps, the distance that you walked is the circumference. Okay, so formulas for circumference, do you need to know these by heart? Yep, and you probably already do, is pi times diameter. But since diameter is 2r, it's also, circumference is also 2 pi r. So you just need to know any one of these, okay? Now, find each of the following, write answers in exact form and also rounded to the 10th. If you put it in exact form, this will be in terms of pi. Okay? We really should have done this lesson yesterday on Pi Day. Anyhow, all right. Next year. Okay, so you need to find C if r is equal to 7 centimeters, right? So C is 2 pi r. If the radius is 7, double it, that's 14 pi centimeters. This is the exact form. It's okay that it has pi, and you can still put units even if there is pi in there. Now, if you want to round it to the nearest 10, okay, go ahead and take out your calculators, please.
So like what is decimal? You just put in decimal form, or will it
Yeah, if I say rounded to the 10th, right? Yeah. So that's rounded. Okay, so here, circumference is 12.5 pi inches, or how much is it in decimal? 39.3 inches. Okay? Okay, if C is 20 meters, find the length of the radius to the nearest 10th. Okay? So C is 20. And you want the radius. So 2 pi r is equal to 20. And if I want to find radius, I need to divide by 2 pi, divide by 2 pi. So r, right? I can cancel these, 10 over pi. That would be the answer in exact form. Or, since it says to round, it's about 3.2 meters. Okay. All right, inscribed. Let's talk about what it means for something to be inscribed in a circle. If you have a polygon inscribed in a circle, it means all of the vertices of the polygon are on the circle. Okay? So for example, here, look at this polygon, LMNP, it's inscribed in the circle because all the vertices are on the circle. So the polygon is inscribed, and then remember how circumference is the distance around? So we say the circle is circumscribed, it's drawn around. To scribe means to draw, right? The circle is circumscribed. It's literally drawn around the polygon, okay? But it has to contain all the vertices of a polygon. So for example, if I have a polygon like this, right? Like L, M, N, P, and then I have a circle like that, that's not inscribed or circumscribed. That's just a polygon inside a circle, okay? All right. Okay. So moving on. Suppose a square is inscribed in a circle with radius 2 centimeters. All right, so I like to draw my circle first. Ooh, look at that beautiful circle I drew. Isn't that nice? Yes. Yes. Okay, and now we're going to draw a square. Circumscribed. Okay? I'm sorry, inscribed in the circle. And the circle has a radius of 2 centimeters. So if that's the center, How would I draw a radii? There, that's a radius, okay, of 2 centimeters. Find the area of the square. Okay, to find the area of the square, I need to know the length of this side, correct? So here's the way we do it. That's one radius. You draw a second radius of 2. Okay, huh? Well, you can do even better than that, okay? What, yep.
The diagonals
Of a square are?
ours.
What are the diagonals of a square to each other?
Perpendicular.
They're perpendicular to each other. The diagonals of a square are perpendicular to each other. So we all of a sudden have a 45, 45, 90 triangle.
So it's 2 round 2.
45, 45, 90, right? So the sides of a 45, 45, 90 are leg, hypotenuse, 2, 2, 2 root 2. Okay? And that's how quick I want you to be with that, right? Just like that, 2, 2, 2 root 2.
So it's 8.
So, okay, so hang on. So, area is now 2 root 2 squared. Now, I want you to pay attention on how we square this one, because this is something that I saw very, very commonly in the chapter 8 test, right? When you're squaring something like that, who does the square belong to? Both of them, right? Okay, so if it belongs to both of them, then area is 4 times 2, which is equal to 8. What are the units? Squared. Okay? All right. Next one. Find the diameter and the circumference of the circle below. Okay, so what we have here is this is a hypotenuse of 3 root 2. But look at this. Do you see how this is a radius and this is also a radius? That means they're congruent to each other. Okay? If they're congruent to each other, what kind of triangle is this? 45, 45, 90. So it's leg, root 2. So this is 3. So if x is 3, you can also label this r or x. It's up to you. Okay? Let's do that. Let's be more. All right. So if r is 3, what do we need to find? The diameter is 6. And then the circumference is pi times 6, which is 6 pi. All right? If you need to put it in decimals, it'll be 18.8. Okay, if it doesn't specify, if on the homework or on a quiz, it does not specify exact form or not, honestly, I would go with the 6 pi, because what if you typed it in wrong? Then you're going to get points taken off. Do you see what I mean? Okay. Find the exact circumference of the circle. Okay, if it says exact, this doesn't mean, do it correctly. That's not what it means. It means put it in exact form. Yeah? Okay, so we need the circumference of the circle. That means we need radius of the circle. Right? Exactly. So if you have 9 centimeters here, what's the difference if you put 9 millimeters there or here? This is also 9 millimeters. That means the radius is how much? Well, you don't even need the radius. You could just use the diameter. So circumference is 9 pi, and this is an exact form. What are the units? Millimeters. Okay? All right, and that's section 1.